Hello, welcome. There's some more. I had one guy coming in very early asking about some type of certifications, but no, this is not the right room for getting certified today.
They switched to certification.
Maybe that's why. Okay. Good point. Okay. Yes, welcome everyone. Yes, thank you for finding your way to this session here. I'd like to talk about the open source project openATTIC, which you may have heard about if you attended Tuesday's keynote and have read some of the news. I just had to change my slides on short notice because now, some things have changed. For example, we're now part of SUSE since this month, which is pretty exciting for us. I'd like to give you a broad overview about where openATTIC comes from, what our motivation is, what features we provide, what we are looking into working on next, the integration with SUSE Enterprise Storage, give you an update over there. Just a very high level, big rundown of everything openATTIC basically. I prefer having more of a conversation, so if you have questions or need, or actually if you have additional information that I didn't provide that you want to get rid of, just let us keep this as a conversation, and I'm open to questions all the time. That's usually a bit more lively than me just giving a monologue upstage. All right, and with that, I usually start with the vision of openATTIC, where it comes from. It has started like so many open source projects that somebody had to scratch his own itch. And because there was no matching solution available back at that time, well, the decision was made that you start something by yourself. It's my special honor to introduce Kai Wagner in the middle of the room. He's one of the founders of the project. He started that whole thing 5 years ago. The company it-novum, where openATTIC belonged to so far, it's a company that also provides IT service management as a service to other companies. It's a spin-off of a larger corporation. And back then there was a discussion about purchasing new storage systems, and the prices of the storage systems offered by the usual vendors were quite high. So they thought, well, we can do this by ourselves. And if you look at it from a technical point of view, basically any Linux distribution that's out there gives you everything you need to set up a very versatile, powerful storage system, to be frank. So the idea was, okay, we take a stock Linux distribution, put it on generic hardware, shove a number of disks into it, and convert it into a file server, basically. So openATTIC's roots are really in what we call the traditional storage systems, particularly the NAS and SAN functionality, the file-based and block-based storage protocols. We support all of them. I have a more detailed list coming up later. And that's how openATTIC started and evolved over time. In a nutshell, it's basically a framework on top of the existing tools and frameworks that are part of any Linux distribution, and adding a web user interface on top of it to make it more easy to manage and use, particularly for administrators that do not have the deep Linux expertise that is sometimes needed. I mean, it's on the one hand, all the technology is there, but sometimes it feels like you have a big box of tools, but you still need to know how to manage, work with all these tools to get the job done, especially if you want to be a bit more sophisticated, and it's not just about setting up an NFS share, but if you also want to make sure that it's being properly monitored, and the whole integration and automation and orchestration of this can become quite cumbersome. So in many cases you will see administrators that create their custom shell scripts that perform these kind of duties, which usually doesn't really scale that well. One of the things that openATTIC also does is providing a RESTful API nowadays, so you have a programming interface that allows you to automate those steps and makes it much easier to integrate openATTIC within your existing environment. And over the course of the, let's say, 2 or 3 years, it was also clear that storage demands are just increasing, and setting up a single server or maybe a pair of servers with local hard disks doesn't scale with the demands and the growth of data that some users see nowadays. And when we were doing research and looking out about alternatives or solutions to address that problem, well, the Ceph distributed storage management came on the radar screen. So the decision was made that in addition to the traditional storage management part, openATTIC should also support Ceph as an alternative for scale-out storage needs. The whole thing is open source. The usual business model, basically, you have a company behind it who releases the software under an open source license and then provides services and support and consulting and the usual things to monetize on the work. But there were quite a number of changes within the last 1.5 years, I would say. From the beginning, openATTIC was dual licensed. That means that you have a community edition licensed under the GPL that was freely available. And in addition to that, they also provided an enterprise edition, which was under a proprietary license, and also included a few additional features that you have to purchase if you wanted to use them. That too is a pretty common or popular scenario of how companies use open source software and still being able to monetize it. In the end, you're selling licenses and not services on top of the software itself. That's a change that we've basically removed. openATTIC was completely turned under the GPL v2, including all the previously proprietary bits. We just now have one edition, which is called openATTIC. We don't make a differentiation between those two editions anymore. Along these lines, this also allowed us to get rid of the requirement for a CLA, which is a contributor license agreement. Previously, even though the software was available as open source, if you were a developer and wanted to make changes to openATTIC and you wanted to return them to it-novum to get them integrated, there was a requirement for you to sign this license agreement that was necessary to allow it-novum to do the dual licensing and change the license, because otherwise you as the copyright owner of this change, well, you would have to agree explicitly to this change, but the usual practice is that you have a blanket statement that every contribution you make, you basically assign the rights to the company so they can make these kind of license changes. But that's a practice that's, well, some companies still use it, but it's always been perceived as a big hurdle to adoption of a project, because sometimes there's real paperwork involved depending on the company and the lawyers involved. So there's a mental hurdle that you as a contributor need to go over first before you can finally submit your patch, even though it's just a minor thing maybe. So there wasn't that many contributions back in that time. And after we've made that change, we could really notice that there was an uptake in the community and there was growth, and users started really getting more interested in openATTIC as a project. And we've also now received a number of contributions with a much more simplified process. We couldn't get fully rid of some formalities here, but we've adapted a process which is called the Developer Certificate of Origin. I think it's DCO, I'm not sure, but it's the process that's used by the Linux kernel and many other projects nowadays, where you basically agree to a single page of terms by just adding a signed off by license to your commit message. That's all that we need. But of course also means that over time, the openATTIC project's copyright is owned by all the contributors. It's no longer owned by a single entity anymore. But it's a model that works out quite well for the Linux kernel and many other open source projects. So far this has really been a very positive change and decision from our end. Also, quite a number of formally internal tools and processes have been opened up to the public. Before, it-novum was the sole developer of openATTIC, and all the engineers working on the project worked in-house. Most of their communications and discussions were taking place in internal mailing lists. The bug tracker wasn't open to the public, so even though the software that came out as a result every once in a while was licensed under an open source license, the rest of the process was pretty much proprietary and closed. And we made a complete 180 turnaround here, opened as much as we could. Everything is now performed fully in the open. So we have a Jira instance that performs both as a bug tracker, but also as a feature tracking tool. So we do our development roadmap planning. We plan our sprints all in the open, and users can submit their own requests. They can comment on everything. They can vote. So we are really open, and we are asking for feedback and submissions and guidance from our users on where this project should be heading. We also changed the way of how the development is done. Formerly, there was just a single line of code, and every developer committed to that particular trunk. We now use branches because we use Mercurial. We perform changes to the code via pull requests, which are then publicly reviewed and approved. And everyone is, of course, encouraged and invited to look at the changes and give their feedback on it. You're probably familiar with these processes if you are following open source projects on GitHub, but we use Bitbucket, which is an alternative, similar infrastructure based on the Mercurial revision control system. So we are not on GitHub at this point. But from a functionality perspective, it's pretty much the same, but it gives us a very tight integration to our Jira tracker. We also changed the release model. We are now on a cadence of once per month. So every 4 or 5 weeks, we cut a release and publish what has been finished and passed tests so far. So basically, it's like a train model. Developers work on features in parallel, and once they are ready and everything has passed the reviews and the tests, then it can be merged into our release branch, and then will be part of the next upcoming release, which also allowed us to really speed up the whole release process. There were a number of other changes, like before, things like our QA and tests and the documentation and the web UI, they were all scattered across multiple source code repositories, which made cutting a release quite hard because you had first to assemble all the various pieces, consolidate them, run an additional number of tests on them after you've made the integration. And now we've just merged this all into one code base, basically, which makes cutting a release much easier and also makes it much easier for a developer. In theory, I, as a developer, can work on a new feature, add all the test cases needed to test the functionality, plus the changes to the modification in a single pull request. So it's very easy to track how both the code and, let's say, the documentation evolve at the same time. Well, and the most notable change probably is that we are now part of SUSE, and SUSE has taken over the sponsorship of the project, like we used to call it. And that really included the entire team, so everyone working for at openATTIC for our it-novum is now part of SUSE. We are basically a dedicated team within the engineering organization, and we will continue to basically work on openATTIC as before. There are no real changes accepted. We will continue to support multiple Linux distributions. We will not just focus on the needs of the SUSE enterprise storage, but of course also really take a close eye on what the community is asking for, what bugs they find. And I wrote a pretty long blog post about that on the openATTIC blog about my thoughts on what this brings to the openATTIC project, but I see this as a very positive development, both for the team, the product, and the community around it. Yes, we're pretty much aware that there are a dozen or more open source storage management projects out there. And well, of course, it's open source, and it's a good thing that you have so much choice. But we sometimes get the questions how we differentiate ourselves, or what sets us apart. One of the key issues really is that we focus on storage management and storage management only. So if you're looking for something for managing an on-cloud instance, or setting up your BitTorrent server, or well, home media streaming, those things are out of scope for openATTIC. We really focus on storage in the data center period. Of course, using the traditional storage protocols, now adding Ceph on top of that. We are fully open source GPL-v2, which means that you can take our software, put it on your hardware, and there's no arbitrary limitation in the amount of storage that you can store in it. There's not something like an evaluation license or a trial license that once you reach a limit of, let's say, 10 terabytes, you are supposed to be paying for the software. Nope. You are free to do with it whatever you like based on the terms governed by the GPL. Which also, of course, helps us to really kind of lower the barrier for adoption, like I call it. So we now, since we have made those changes, we get lots of requests by hardware vendors, for example, who want to pre-install openATTIC as part of an appliance that they would like to ship to their customers. So we're seeing a lot of uptake here and get quite a lot of interesting requests around that. One of the things that we are also pretty proud of, it's pretty much based on stock Linux. We are not based on a Solaris derivative. It's not FreeBSD underneath. The problem that at least I see with those operating systems is that they simply lack vendor support. Most hardware vendors nowadays are pretty good when it comes to supporting Linux with their device drivers. They work very closely with the Linux distributors on the certification of things. If you're looking at FreeBSD or the Solaris derivatives, it will be much harder to design and define a server system that matches all the requirements from a driver perspective. And well, it's not just one Linux distribution. We try to make a point of being available in installable form from the most common Linux distributions out there, namely Debian, Ubuntu. We added support for RPM-based distributions like CentOS, RHEL, and now SUSE over the course of the last year. So that gives customers or users much more choice. They can stick to the Linux distribution that they prefer. Of course, it means somewhat more work on our end because no two distributions are alike, even though we would hope that would be the case. It's interesting to observe on how many subtle levels the various Linux distributions have diverged over time and make our life very hard sometimes. But it also helps us to tap into a very large user base, and well, especially the hardware certification aspect is quite helpful for us. If we have users asking us what hardware we support, we can simply point to the Linux distributor. They have their own hardware certification lists, and everything that's supported by the operating system is supported through openATTIC automatically as well. All right, some high-level features. We started working on openATTIC version 2 about 2 years ago. One of the major highlights here is that we completely revamped the web user interface that you see. It's now based on much more modern web technologies, AngularJS. And we also changed the way of how you talk to openATTIC through the API. The former version, openATTIC 1.x, was based on XML-RPC, which is a bit more complicated to handle. Nowadays, most applications provide RESTful API, so that's the route that we have selected as well. From a storage perspective, the focus is pretty narrow. It's the file-based protocols, NFS, CIFS, or HTTP shares if you need them. On the block level layer, it's iSCSI or FibreChannel, and we use the LIO Linux iSCSI framework for that. We support quite a wide variety of file systems. You, as a user, can really choose the file system that suits your workload best if you create a particular share. The usual suspects like XFS or ext3 and 4 are available. We also support Btrfs, which gives us some features like checksums, snapshots, and things like that. And we also support the ZFS file system, which was formerly derived from OpenSolaris, which gives us other nice features like block volumes, snapshots, and again, checksums. ZFS, of course, is something that you usually have to add and install separately if you're not on Ubuntu Xenial, which is currently the only distribution shipping it by default. The reason is that the ZFS license, the CDDL, is per se incompatible with the GPL license used by the kernel. So the ZFS file system cannot really be distributed together with the Linux kernel if you don't want to violate the license. But Canonical thinks they can do that. I'm not a lawyer. I'm pretty sure it's a gray zone there. In addition, we support multi-node. So if you have a single server with disk and you need more space, you could set up a second machine, install openATTIC on top of that, and both openATTIC instances can, if they share the same metadata database, you can manage both instances through the same web interface. We also have added support for the DRBD, which is basically a block device that is mirrored via the network to the other nodes, so you can set up a mirrored volume for redundancy purposes. Also, we have a backend infrastructure that configures Nagios to monitor the various resources that you create. So if you set up a new volume, we'll automatically reconfigure the Nagios instance to also acquire performance data for that particular volume to create the performance graphs that you see in the UI. And of course, now with the help of SUSE, we have really accelerated our whole work around the Ceph management and monitoring story. The first incarnation will be seen in SUSE Enterprise Storage 4, which is about to be released later this year. And even though openATTIC as the upstream project supports all these features, the instance or the incarnation, how I would call it, of openATTIC within SES4 will be trimmed down in scope for just doing Ceph management and nothing else. This will likely change over the course of time, but for the initial version, we decided to focus on the Ceph management parts only because, well, that's what SUSE Enterprise Storage is all about. It does Ceph. Which doesn't mean that at some point we might add more functionality or come up with new ideas on how openATTIC might be useful. From a technology perspective, openATTIC can basically split into two major components. You have the backend on the one hand side, which is a Django application, so it's written in Python. And we can then make use of the whole ecosystem of tools and frameworks that are around the Django project, which is a pretty mature and well-developed community project. For example, the Django REST framework automatically gives us the RESTful API that we have on top. It also means that the code base that we are based on is, even though it may sound boring, it's pretty mature and well developed, and it's not bleeding edge stuff, which of course is important if you as a user want to put this software in your environment. It also gives us an easier chance to capture the attention of other developers. Python by now is very well known. You get lots of developers, and the learning curve isn't as steep as for other programming languages. So the Django application basically has the logic and the business intelligence designed in it, and it then uses the traditional tools that you would usually use on the command line to perform the duty at hand, like, for example, setting up an NFS share. Well, we added the etc/fs tab file, or to restart the service, we would call systemd or whatever. We have a separate process running with root privileges that accepts commands from the Django application to perform the duty at hand. In theory, you could perform all those steps manually on the command line to reach the same result. What openATTIC really does is the whole orchestration and automation of these steps to make it easier for you. As I said, Nagios is used for the monitoring. SUSE added support for Icinga because that's their default monitoring solution in their distribution. And then we use the PnP for Nagios plugin for the graphing and the performance monitoring. The web application also is pretty stock web application stuff. AngularJS and Bootstrap both have been around for a while. There's a big pool of developers around it and a good community. So this is what gives us the web user interface. And it communicates with the backend through the REST API exclusively. So everything that you can do through the UI could in theory also be performed via a shell script or a curl command or a Python script or whatever. So it's very well, it is possible to set up openATTIC in let's say, a headless mode where you don't really have a UI to manage it, but have maybe an external application performing REST calls to openATTIC to create new storage or to delete it. We put a large focus also on testing. So we have basically unit tests for all the Python modules that we've created. For the REST API, we've created our own test suite, which automates pushing REST API calls and evaluating the results coming back again. That's our own development. We also automatically test the web UI by basically remote controlling a browser, which then performs clicking the web interface, entering content into the fields and so on, which is based on the Protector Jasmine toolkit. And if you have any questions or any comments, let me know, yeah? So this is more of an architectural view of this whole thing. As you can see here, what we call the openATTIC backend based on Django sits in the middle. We use a small Postgres database for persisting some of the information that we need to keep track of. If you have multiple openATTIC instances, they would both talk to the same Postgres database. So that's a shared component that acts as the synchronization point between those two nodes. Then we have this process running as root. It calls itself systemd, but it's not the Leonard Poettering systemd, it's the openATTIC systemd. By coincidence, it shares the same name. That uses the dbus protocol to exchange information. And systemd is the one that performs, with root privileges, all the commands that you need to configure your subsystems. So once you have created your shares and your storage system is up and running, you could basically just shut off this entire stack on top, and it will still continue up and running without the monitoring maybe, but the server functionality is served by the Linux operating system underneath and won't get disrupted by any changes or failures of openATTIC itself. With Ceph, we have started a slightly different approach, as you can see here. The first interface that we use to communicate with the Ceph cluster is called librados, which is one of the default APIs that you need to talk with the Ceph cluster. In this way, data between the Django application and the Ceph cluster is exchanged directly without any persistence layer like a database in between. That was a very important design decision because unlike if you have a local storage system where openATTIC runs on the node, you can pretty much assume that openATTIC is in control of all the components. And basically, it's fairly safe to persist the state of the system in a database. But with a distributed system like Ceph, this would quickly run out of hand because the Ceph cluster might be in a completely different state. And you also want to still make it possible for administrators to manage Ceph with other tools without having to resynchronize the database of openATTIC all the time. So we had to make some tweaks on how Django works internally to make that possible. Okay, so these are just a few ideas of our plans that we have with regards to storage management. We are by no means done with what we want to do yet. So one of the shortcomings that we currently have, and that's basically mostly based because we also now have moved to version 2, is that on the traditional storage management side, the creation of a storage pool, like for example assembling a number of disks within a logical volume group, needs to be done on the command line once. And once you have the volume pool created, then openATTIC can take over and start carving out volumes and manage those. So that's a shortcoming that we need to address pretty quickly. More sophisticated ZFS pool configurations or Btrfs with RAID functionality, all these things still need to be performed manually, but we intend to make that manageable through the UI at some point as well. Disk monitoring with smart hardware RAID controllers. We do support 3-way RAID controllers, but they are somewhat obsolete by now. And yeah, the question is if it's still really necessary, or if the RAID support in the Linux kernel is good enough by now. So we're still on the fence about that. Also, the openATTIC team has quite a number of things on its plate. So at this point also, we are very open to feedback and getting requests from users so we can kind of count how important some functionality is for the community to make sure we have our priorities right when it comes to the storage management part. DRBD volume mirroring is part of the backend for quite some time. The only missing component is to add the flag in the web UI so that you can enable mirroring for a device. So that shouldn't be a big deal. Sorry about that. and we have that on the plate as well. There's a lot of more when it comes to iSCSI and FibreChannel that we could do. So the Jira has it in much more detail. We usually have what we call epics, where we consolidate a number of issues and tasks that we still would like to address at some point. So I'm going to point you to that. We also have a few wiki pages where this is somewhat in a more condensed fashion, so you don't have to troll the Jira for everything. Okay, I'm going to focus a bit more on Ceph to conclude this, because that was really what kept most of our attention for the last year, I would say, particularly because of the development cooperation that we had with SUSE, who was very interested in, particularly in the Ceph management part of openATTIC. Again, like with storage management in general, there are a number of other open source tools that do Ceph management in some form or another. Well, we looked at these and we tried to get a feeling for what functionality they provide, but we didn't really want to mimic another tool one-to-one and just map the features that they already have. So we are more taking up a bottom-up approach here, I would say, in that we start with, okay, what are the most common features that a Ceph administrator needs to run into? And how can we start with low-hanging fruit and addressing these first to give some value to the user to begin with? Of course, one of the things that can easily happen if you have larger clusters is that there's simply an abundance of information and you're just being overwhelmed with all the data that you get. So we are thinking about how to make it much easy to quickly grasp the status of a Ceph cluster through the UI without you getting inundated with detail or completely overwhelmed. And of course, as I said, you should be able to still make changes to your Ceph cluster through the command line tools without openATTIC getting confused because of that. And if somebody could bring me a cup of water, that would be terrific. I see my voice is getting down the drain.
Just one cup?
Yeah, that's fine. Thank you very much. Let's see, how are we with time? Okay, that's good. So we started Ceph development 2 years ago, and with the help of SUSE, we really managed to accelerate especially developing that part within the last, thank you very much, more than a year or so. The current state is that we've basically, from a backend perspective, we had to come up with we had to overcome a few shortcomings, let me put it this way, that are just referring to that. On the one hand, the Django application with the database, how do we do that when we talk to a Ceph cluster? The outcome is what we call NoDB models. I don't know if you're familiar with how Django does data design, but usually Django is being used for creating web applications like a web shop or some company website. But in fact, the way you can structure the objects and data within Django was a perfect fit for creating a storage management system like openATTIC. For example, a disk is a model of its own, and then you have pools as another model, and you can define the relations between those. But by default, Django expects that the definition of the table behind those is persisted in the database, and the Django application queries the database for the content. And while we liked using the Django models, the dependency on the database had to be overcome. And the NoDB models basically cut off the database layer, but instead there's an abstraction layer where the data that we want to retrieve is being pulled from the actual object that we want to manage. In the case of the Ceph cluster, we define Django models, but the data is coming right out of libraders from the Ceph cluster directly. So we basically misuse the metadata from the Ceph cluster as the database table, to put it this way. Also, some tasks in a Ceph cluster don't return immediately. So some of these operations are ongoing and take a while before they come back. And some of these commands just hang until they're done, which is not really what you want to do with a web application, because at some time your web browser will simply time out and waiting for the result. So we had to come up with something we've called the task queue, which is basically a separate piece of code in which you can schedule tasks that the Ceph cluster should perform, and it keeps track that it's making progress, and you get a report once it's done, or there's an error or whatever. In fact, this particular part is under consideration to be integrated in the Ceph manager of upstream Ceph, because they face the same problem, and they're currently working on a separate tool that is supposed to be kind of consolidate some of the Ceph management functionality in one tool. So we're working with the Ceph developers on how we can donate that functionality to them to have it part of upstream. Another interesting project that we're working with at SUSE is what the DeepC project. DeepC is basically a framework on top of Salt that is used to orchestrate the deployment and configuration of an entire Ceph cluster from scratch. So using Salt, basically you have a Salt master, and then you start a number of minions, and once they register, you are able to assign roles to these minions. For example, let's say you are going to become an OSD node, or you are going to be a Ceph monitor, or you are a Rados gateway. And then Salt takes care of performing all the various steps involved in configuring that node to perform that role. And basically, openATTIC will become a RESTful API and UI on top of DeepC. I guess that's how we can put it. The first steps have been concluded here. We are now able to read out the pillar data from DeepC to get a list of all the minions and their roles and some other information about what role they have. And if you add a new node using DeepC, it will also be added to the list of the minions that we can display. Further down the road, it will be possible that if you add a new node, openATTIC will send you a notification, hey, here's a new minion, what role should it have? And then you can basically have a drop-down box, select the role, hit apply, and then that node will be reconfigured and added to the Ceph cluster transparently in the background. These are all pretty deeply Ceph features. We have added Ceph pool management and monitoring. So by default, Ceph comes with a number of pools that are created by default. You can create new ones, both replicated or erasure coded. We also set up monitoring so you can see the utilization and the I/O. We have created a cluster health and performance dashboard, which you can customize to your liking. So you see how is the entire Ceph cluster doing? Is it healthy? Is there a problem? How is the I/O doing at the moment? Again, we use Nagios at this point to store the runtime data and visualize it. We've put some effort into making it a bit more beautifully looking. I don't know if you're familiar with PNP for Nagios graphs that are usually, these graphs have been around since last century basically. They have a very particular look to it because they're coming out of the RRD tool. With the Ceph Dashboard and the pool performance monitoring, we are now using JavaScript libraries to visualize the data within the browser. So it's not a static PNG that is displayed, but rather we just pull the runtime data and then use the browser to render the information, and it allows you to, you have more possibilities to work with the data on the web interface, basically. Yes, we have a crush map editor. The crush map is basically the algorithm that defines the redundancy of your Ceph cluster, how data is being distributed and replicated. And that usually is a bit inconvenient because the crush map needs to be decompiled into an ASCII file. You have an ASCII editor. Once you have made your changes, you have to compile and upload it back to the Ceph cluster again. The crush map editor is supposed to make that a bit more easier, but it also makes it much more easier to shoot yourself into the foot. So therefore, for SES4, we have converted it into a crush map viewer, so you can only see the existing crush map. The reason is that making changes to the crush map and applying these changes in a busy cluster can disrupt your service because the cluster becomes very busy with itself making those changes. So basically the most common objects of a Ceph cluster, like the object storage daemons, Rados block devices, Ceph Pools, you will now have views within openATTIC that show you the details. You can get performance graphs. You can create and delete those if you want to. And over time, we will add more and more functionality to these existing views, but also add more functionality on top of that. Again, in a monthly cycle, upstream openATTIC will continue to be on a monthly schedule, and the Ceph functionality will evolve over time as well as the other features. And then SUSE Enterprise Storage will take a snapshot of what has been ever developed and use that as the basis for their next product. And one of the things that many of the other tools can't do, we also support multiple Ceph clusters in one openATTIC instance. So if you have a production and a testing Ceph cluster environment, both can be managed through the same instance of openATTIC. And you can also create dashboards where you can basically have both graphs of your Ceph clusters next to each other for comparison purposes, for example. Roadmap, yeah, future work. We have a long to-do list, and some of this is still under debate or might be rescheduled. Right now we are happy that we have reached that point that we are at, but of course there's much more. For example, ZFS management and monitoring is very high on the list. The task queue implementation, yeah, that's going to migrate to Ceph Manager in the meanwhile. In addition to being able to just create and delete objects, sometimes you also maybe want to modify them, like Ceph Pool details. So you will see with each release more and more buttons and features appearing over time. And since we are on a monthly release cycle, we also would like to encourage users to toy around with it, give us feedback, and let us know what they're missing, how they like the current implementation, what needs to be changed. And really, of course, we have a vision and an idea of how this should look like, but in the end, we develop the software for the user and the administrator. So we are really looking forward to getting honest and brutal feedback here. And the whole integration with DeepC, of course, is a major construction site at the moment. As I said, the vision is that you will be able to deploy nodes by selecting the role, and DeepC goes on. But in addition to that, we want to be able to have more insight into the individual nodes that a Ceph cluster consists of. There's only so much information that you can obtain through Ceph directly, but you need to combine it and fuse it with the information that you get from the operating system. Case at hand, for example, is that the object storage daemons, the OSDs, they all write data to disks, but Ceph doesn't really observe the disk I/O performance, and the Linux operating system sitting underneath the OSDs has much more detailed information about that. So we're looking into ways of how to obtain that information from all the various nodes and consolidate it and make it more easy accessible to the user. And one of the candidates that we're looking here is a tool called collectd, which is a very lightweight process that sits on each of the nodes and performs the data collection. And then, since it's very pluggable, you have multiple ways on how the sampled information is being stored or sent to another node, for example. So collectd is very flexible in that respect. Eventually, I personally would like to get rid of the whole Nagios Icinga combo at some point and be a bit more open and flexible here. And well, again, there's a wiki page where we kind of consolidate the plans and ideas that we have. And this is a living document, so nothing on there is really cast in stone. It really depends on the feedback that we get and how the priorities change. All right, some screenshots to finish off with. This is the traditional storage management dashboard that you start with. So you see your servers currently utilization, you see your disks, how much of them are currently up and running, overall disk load, CPU load, and those graphs change dynamically. A bit eye candy here. One of the things that we've added with version 2 are what we call wizards. Before, in the first version of the web UI, we had a very deeply nested tree of features and options. So if you as an administrator, for example, wanted to create a new NFS share, you would still have to know which steps to perform in which order, that you first have to create a new logical volume, put a file system on top, and then convert that into an NFS share. Version 2 has this whole framework or wizard framework in where you are being guided through the various stages step by step until you have reached the result that you want to get with. as I was talking about those century-old graphs, this is the old graphs created by PNP for Nagios. This is the traditional storage management part, so you have a number of volumes here. You can see, well, it's probably not easy to see, sorry about that, but each line basically is an individual volume with its status, with its utilization. If you click on it, you can get more details like the usage graphs and the performance. That's a nifty little tool that I haven't really seen in any other web application, and that's why I want to mention it. We have added an API recorder to the UI. What it basically does is that it collects all the API requests that are being performed while you are performing some operation through the UI. Like you click on create volume. If you start the API recorder before, it will take note of all these steps. And when you stop the recorder, it will create a small Python script that you can cut and paste, which will then repeat those steps. So if you are a developer and you are lazy and don't want to read up the API documentation just to perform a single task, just go through the web UI once and you have a little template script that you can then use for your own purposes. And that's the new Ceph cluster dashboard. This one sports the stock openATTIC branding, as we call it. The version included in SUSE Enterprise Storage 4 has of course, the SUSE branding with the right color schemes. You can see a preview of that in the exhibition hall downstairs. We have a demo running there if you want to take a look. The nice part about the new dashboard is that it's fully customizable, so you can move all those widgets around, you can resize them, you can delete them, you can create multiple dashboards if you like, and the dashboard configuration is stored with your user profile. So every administrator with his own user account can customize the look to his own likings. How am I doing with time? Oh, okay. Ceph Pools. So this is the new graphs that you see here. Performance graphs for a Ceph pool using the formerly mentioned JavaScript library that we use here. On top, the look and feel is pretty much the same like in the other views. Of course, we want to make it consistent that each of the views basically sports the same look and feel. That's a dialog for creating a pool. Here we're choosing an erasure-coded pool, but we also support replicated pools. We have a live demo. A link will be shown up shortly, so if you want to toy around with it and get a feeling for it without going through the install, you can do that. The demo is being refreshed every top of the hour, so don't be surprised if your changes are suddenly gone if you're happening to be around at that time. That's the Ceph OSD list. I'm going to speed through these real quick. Rados block devices. And of course, if you're, for example, using Ceph as your storage system for, let's say, OpenStack, all the block devices that are created by OpenStack would also be listed here as soon as they are created, because we dynamically query the Ceph cluster for that information. RBD creation, so we support all the various features here. This is basically the first incarnation of those dialogues. In some, sometimes they feel a bit raw in that they ask for quite a lot of information, and you still need to be very knowledgeable about Ceph to make sure that you enter the right information here over time. And we intend to also create more streamlined versions, assume safe defaults, or create wizards that even guide you through the various steps involved to make it easier for you. That's the famous crush map editor. One nice thing about it is that you really have a visual representation of your various failure domains and the rules associated to them. So it gives you a quick glance of how you have basically defined your virtual data set within Ceph and how much levels of redundancy you have. And here we are. This is just the link collection. openATTIC.org is the stock URL, and from there you will find links to all the other information. If you want to chat with us, we are also on Freenode /openATTIC. Otherwise, we have a Google group which acts as a forum/mailing list if you want to discuss things with us. I always encourage our developers to put as much of the discussions into the open group. so people can get engaged and get their feedback. But if you have any questions or problems, just post a message, then we'll get back to you. And with that, I still have 10 minutes for questions. If there are any. Food is dragging you down on your chair, I know. I hope this wasn't too overwhelming. Okay, there's a question. Yes?
Does the traditional storage manager also support de-encrypt, so encrypted devices?
The question is if the traditional storage manager supports de-encrypt, and the answer is not yet within openATTIC, but if you set up a block device using de-encrypt on the command line, openATTIC can make use of it, and then you're free to go. But yes, that's one of the features that I would like to have as well. Yeah, so unfortunately, work in progress. Okay, then I spare you 10 minutes. Thank you very much.